Welcome. Thank you for joining this webinar on the final day of Social Sciences Week. My name is Chris Hatley. I'm the CEO of the Academy of the Social Sciences in Australia. And before we get going, we're just going to play an acknowledgement of country video, recognising the different traditional lands from which we're all joining this afternoon.
Wherever you are across Australia,
we acknowledge the traditional owners and custodians of this land.
The Darug peoples.
The Gadigal people of the Eora Nation.
The Gundungurra people of the Southern Highlands.
The Ngunnawal people of the Canberra region on whose country we are standing.
And all other peoples of this vast continent.
Their ongoing connection through custodianship of its land and waters.
Physical and spiritual.
Through culture, language and ceremony.
Where sovereignty was never ceded, we pay our respects to elders past, present and still to come.
Thank you. And from my part, I acknowledge the Ngunnawal people, the traditional owners of the lands in Canberra, where I'm joining this afternoon. So we're here this afternoon to hear from Dr. Tim Neal, who is a recipient of the Academy of the Social Sciences in Australia's 2021 Paul Bourke Award. Now, the Paul Bourke Award is named after the late Paul Francis Bourke, was a historian and a past president of the Academy of the Social Sciences from 1993 to 1997. And he was known by those who worked with him and knew him for his dedication to supporting junior colleagues and supporting early and mid-career researchers. So it's fitting that this award is named in his honour. The lectures are presented each year by the recipients of the previous year's awards, and the awards honour researchers in the early part of their career who have achieved excellence in scholarship in one or more fields of the social sciences. So Tim and several others were recipients of the award last year, and we will shortly be announcing the 22 recipients, and you'll be able to hear from them in Social Sciences Week next year. I should also acknowledge that the lecture is jointly hosted this afternoon by the Academy and by UNSW for Social Sciences Week. So our appreciation to the University of New South Wales for their support. So with that said, I would now like to introduce Dr. Tim Neal. So Tim is a Senior Research Fellow at UNSW in the Department of Economics and in the Centre of Excellence for Population Ageing Research. He's published in leading economic journals in areas as diverse as climate change, which we'll be hearing about today, machine learning, child labour in developing countries, panic buying during the COVID-19 pandemic, it's still a recent memory, and his future research agenda includes the exploration of global economic impacts of climate change and biodiversity loss, as well as developing new methods to examine causation in deep learning models for use in economic analysis. So, Tim, over to you.
Hi, everyone. Thank you for coming today. And thanks, Chris, for that introduction and for Anna Dennis for organizing the event today. So I've had some technical problems with the slides, so Anna's going to be helping me share them. Hopefully you can all see them right now. Excellent. Okay, so it's Friday afternoon, and I've no doubt many of you are in need of something uplifting and optimistic to help get you to the weekend. And unfortunately, today I'm talking about climate change, which is neither of those things, but I'll try my very best. Okay, next slide, please. Okay, so what does this talk about? So really, I'm asking the question, how bad is severe climate change going to be for the world economy? So when I say severe climate change, I mean anything that's beyond, say, 2 degrees of warming. And this type of warming is quite likely to occur unless we see significant change in the world's current policies. I'm going to be focusing on the global economy, not Australia in particular, but it's of course highly relevant for Australia as well. And I'm going to be asking, what are the various channels through which future climate change can affect our livelihoods? And I say livelihoods because I want to focus on the fact that economic implications of climate change really has to do with our future standard of living and those of our descendants. Now, I'm going to talk about how there's a fundamental contrast between how scientists and economists characterize the implications of climate change for society and the economy. I'm going to argue to you that this contradiction is based on poor assumptions made in the economic modeling. And I'm going to be talking about future research and how we can fix that problem. And everything's going to be at a very high level. No economics jargon today, no mathematical equations or anything like that. So don't worry. Next slide, please. Thank you. So let's talk for a minute about climate change and the economics profession. So climate change, of course, refers to this idea that the concentration of greenhouse gases in the atmosphere is causing changes to our climate, such as increases in mean temperature, more frequent weather events, extreme weather events, and other things like the acidification of the oceans. So from the outset, we can see that economics really lies at the heart of climate change, because it's economic activity itself which causes the change in the climate, insofar as that activity relies on the burning of fossil fuel, which until very recently has exclusively been the case. Now, all empirical economic research relies on this idea that we can analyze a policy or economic phenomena by looking at how certain things change while holding other things constant. And that's very important for us to be able to do our job well. And in mostly all prior research, one of the main things that have been held constant is the natural environment in which economic activity actually takes place. And with climate change, we see that assumption break down. And this has led to a number of basic presumptions in economics, which to me now look suspect. This idea that economic growth is unabashedly positive, and this idea that the environment is an isolated sector of the economy. It's impossible to value in monetary terms, and therefore a niche area for economic study. You know, environmental economics has its own journals, it has its own conferences, and it's kind of its own thing. What I'm interested in is the question that if economic activity changes the long-term equilibrium of our climate, will a different climate change the long-term equilibrium of our economy? And to me, it's hard to conceive of a more important or relevant empirical question in the discipline right now. And on the left here, I've put a quote from one of the very influential economists in this area who's writing a survey article for the Journal of Economic Perspectives. And this is one of the most widely read and cited economic journals that there is. And what it hopefully shows you is the attitude that certainly not all economists, but a significant amount of economists, the attitude that they've had towards climate change and the study of it. Next slide. Thank you, Anna. So let's talk first about what the scientists are saying. So the IPCC synthesizes abundant scientific research that outlines the potentially severe impacts of future climate change. Stabilizing climate change around 1.5 degrees Celsius, which is probably the best that we will be able to do, is characterized in the science literature as a human imperative. And this was a landmark paper in 2019 in the journal Science. It's a human imperative. This is something that we as a species must do. Recent research in very very prestigious science journals is even starting to explore the risk of worldwide societal collapse or even extinction from severe climate change. And these are in, as I said, very prestigious journals. These aren't, crackpot blogs or anything like that. Meanwhile, deforestation and overfishing is working alongside climate change to cause precipitous declines in biodiversity and animal populations. And this will have its own set of implications for us. And for example, there's the work of the IPBES, and that is kind of the equivalent of the IPCC for biodiversity decline. Now, it's natural to interpret these, what could be seen as resounding alarms, to mean that climate change is going to have a profound impact on the global economy. That would be the natural assumption if you were reading the science journals in certainly the last 10 years. Next slide, please. Which leads us to, well, what are the economists saying? And Unfortunately, well, perhaps fortunately, economic models predict that severe climate change is going to cause between positive 2%, that's right, positive 2%, to negative 23% of damage to global average GDP per capita by 2100. That is what the economic models, the variety of them that have been devised thus far, that is what their predictions are. And most models' predictions lie within the -1 to -12% range. And while anything beyond -10% is noteworthy, certainly, and meaningful, it's hardly a global catastrophe. And in fact, if you think about the next 80 years, technological progress is certainly going to overwhelm -10% of damage to world incomes. Virtually all economic models predict that a significant number of countries may benefit or be relatively unaffected by climate change as well. These are countries like Russia, Northern Europe, and Canada. So what I'm interested in is, why is there such a big gulf, such a big contrast between what the scientists and the economists are saying about severe climate change? And that is going to be the topic of this talk. Next slide, please, Anna. Thank you. But before we talk about that, let's go through what are the various ways in which climate change can impact the world economy. How is this effect actually going to materialize? So on the left, I just show you that climate change appears in our environment in a number of ways, things like sea level rise, heat, or increased probability of extreme heat events, and extreme weather. And all of these things will themselves have an effect on economic activity in various ways. So on the right, I try to categorize in a very loose and very subjective way what some of these possible channels are. And I'm going to categorize them from left to right, first by, again, loosely categorized by the degree of potential impact between less and more. And I also categorize them from bottom to top with the degree of confidence that the literature has in how likely these things are to happen, and if they do happen, how severe or how bad will it be. And in the areas that we do have some degree of confidence, we have things of potentially high impact, such as asset loss from extreme weather events and sea level rise. We have crop yield impacts, health impacts, and we have things that might have less potential impact, like the impact on groundwater and fisheries. Now, I say these are lesser impacts, but if you live in a part of the planet that now no longer has, that won't have access to clean water in the future from climate change, this is going to be an extreme impact to you. But on average across the planet, this is how I loosely organize it. But then there are a number of potential channels that we have almost no real understanding of what the potential impact could be or how likely they are to happen. And the first of these is conflict and war. So it's natural to expect that as natural resources decline and the competition over those resources increase, there's going to be more conflict between countries and within countries. And with the proliferation of nuclear weapons, it's easy to imagine this having potentially catastrophic impacts on the global economy after a nuclear exchange. This is not just due to the direct deaths from a nuclear exchange, but the soot that is put into the atmosphere that will cause widespread crop failures if it's a significant exchange. And then there's also things like biodiversity collapse. So our species relies on biodiversity in very complex and very fundamental ways. And if there were to be a complete collapse in biodiversity from severe climate change and deforestation, I don't think anyone can say right now with much authority what it would actually mean for things like our ability to pollinate our crops or have fertile soil in the first place. There's also zoonotic virus spillover, and this is an interesting one, especially given our recent experience across the world. There's a lot of evidence in the literature that human-wildlife interaction significantly increases the risk of viral spillover, which makes perfect sense. And climate change is going to exacerbate this. And only the last couple of years, really, since COVID, do we fully appreciate how dramatic the implications can be from viral spillover from animal populations. Next slide, please. Thanks, Anna. So let's drill down into what some of these mechanisms are and what we know about them. And this will help us get a better understanding of what the potential impact on the economy could be from severe climate change. And it's natural to start with crop yield because we all rely on agriculture for our survival, of course. And agriculture has undergone a real revolution in the past, in the 20th century. So agriculture used to be a very large proportion of each country's GDP. You know, even as recently as 1950, agriculture in India comprised half of their total GDP, whereas now it is close to 10%. And the reason why its share of GDP has dropped so much in the last few decades is because of the mechanization of agriculture. Crop yield, or what crop yield means, is our ability or how much crop we're able to grow for a fixed amount of arable land. So this is really how productive and how efficient we are in growing our crops. Crop yields have increased dramatically due to technology and other things over the last 60 years. And also real food prices are strongly linked to crop yield, or our ability to grow crops. And prices are linked to other things like conflict and things like that. On the right here, I have this graph that goes from 1960 until now that shows the real average food prices that the world experiences in each year. And we see from 1960 until the early 2000s, a very dramatic drop in food prices. And for various reasons, that trend has reversed. And it's actually spiked to the largest value it's been since 1960 now, due to COVID and Russia's war in Ukraine. And this has really been an amazing thing for us as a species, because the world population has exploded and we've really relied on crop yield booming in the last 60 years so that we're able to even feed all the people that we have now. Unfortunately, recent studies have found potentially severe effects of climate change on crop yield of staple crops. So on the bottom left here, I have a graph, and this is from recent work by myself and my co-author, Professor Michael Keane. Here we forecast corn yields in the United States out to 2100 using various emission growth scenarios. I know this graph is a lot to take in with zero context whatsoever, but we have historical corn yield growth from 1950 until the present. And then we have these three lines. And these three lines are our forecasts under different emission growth scenarios or climate change scenarios. The purple one, RCP 85, represents extreme climate change of more than 4 degrees Celsius. The orange line, where we see yields are stagnating, that RCP 45, that represents climate change of between 2 to 3 degrees Celsius, which is probably the most likely to occur, assuming the world's current policies and ambitions are maintained and don't regress. And then we have RCP 26, which is really what the Paris Agreement would want us to be at by the end of this century, but and hopefully it happens. What we see from this graph is corn yields potentially declining dramatically, depending on the climate change scenario. And corn is a crucial staple crop because unlike many other crops in the world, it's still enjoying increasing yields in recent times. We see that if the purple line were to occur and for corn yield to actually not only stop increasing, but to actually go down in the future, this would be an extremely dramatic result, especially because we're looking at the United States here, and the United States is a relatively cooler country. So if corn yield is suffering, if staple crop yield is suffering so much in the United States, then what it means for developing countries and also countries like Australia would be even more stark. Also on this graph, I show in the dashed line the total human population. Now, obviously in the future, we don't know the future population, but this is the median UN projection that they're projecting is very likely to occur. And we see that population keeps increasing. Now, if population continues to increase in the future and yields stagnate or go down, this is a disastrous result and will have terrible implications, not only for food prices, but also mass starvation. Especially in developing countries in the future. Next slide, thanks, Anna. So that's crop yield. What about some of these other mechanisms we can touch on briefly? So asset loss is probably the most widely popularized impact of climate change. Sea levels rise, that destroys coastal infrastructure, but also things like extreme weather events has also a potential to inflict severe damage. And we've certainly experienced that in Australia the last few years. It's not only the frequency and severity of extreme weather events, but the compounding of events that matters. Because if human populations are exposed to an extreme weather event, that makes them significantly more vulnerable to bad impacts from subsequent events. So if two extreme weather events were to happen in close proximity in time in the same location, that can lead to exponentially worse damage and worse outcomes for the humans that live in the area. Now, the frequency matters of these events because beyond a certain threshold, there comes a point where governments can no longer rebuild damaged infrastructure and private companies can no longer insure assets in parts of the world that become very problematic. And even in Australia now, we're having a discussion at the moment of whether we should be building housing developments on floodplains and wildfire-prone areas, and whether these areas will even be insurable in the future, and whether the government should start buying back properties to correct this mistake. Conflict is another one, and I talked about it a bit before. There is evidence in the literature that shows that climate is associated with conflict in all forms, interpersonal, within country, between countries. And in the security think tanks around the world, climate change is starting to be seen as one of the leading security risks of nations going forward as the competition over resources increases. Next slide, thank you, Anna. So next is human health. So one of the most prestigious medical public health journals in the world right now, The Lancet, they annually review the health implications for a warming world with their report Countdown on Health and Climate Change. And they identify a few key fundamental things. So they note that additional exposure to extreme heat causes additional mortality and health complications, and a variety of other things. And so does heightened transmission of pathogens. Those are the two key risks from climate change. Not just the spillover of zoonotic viruses, but also bacteria and many other types of diseases will have more spread in a warmer world. Furthermore, insofar as climate change compromises our access to clean water, nutritious food, and stable employment, those are all going to have significant health implications for the world population as well. Relatedly, there's also a recent literature on the impact of climate change on labor productivity. So it's reasoned that warming may affect labor supply decisions quite significantly, especially in sectors that are exposed to the climate like agriculture, construction, and mining. Not only will it affect labor supply decisions, but it can also reduce the very productivity of that labor. So dehydration and heat stress, excuse me. So dehydration and heat stress increases the number of mistakes and the need of rest for laborers. Now it's, in Australia, especially in office buildings, we do have widespread access to air conditioning. And we're often quite insulated from these types of problems. But in many countries that don't have widespread air conditioning, really all types of labor are going to be implicated in this impact, not just outside work. And even when air conditioning is present, warming may increase the frequency of temperature events that are above the air conditioner's maximum operating temperature, which is usually between 37 to 40 plus degrees Celsius. If you start seeing events beyond that amount, an air conditioning system or energy grid starts to struggle to cool homes, and the ability to condition your home collapses, then that could really cause problems in even advanced economies as well. And there's a recent paper by Dasgupta and co-authors in 2021 that predicts significant reductions in labor supply and productivity across key sectors from the type of warming that we would see from severe climate change. Next slide, thanks, Anna. Okay, so hopefully by now I've convinced you that there are a variety of different mechanisms through which climate change can affect the economy. And the question now is, how can an economist possibly obtain realistic estimates for all of these and combine them in a way that will give us an overall assessment of the impact of severe climate change in the future for world prosperity? So I'm going to briefly outline 3 different methodologies that economists have used in the past to kind of tackle this issue and get an overall impact assessment. And the first one of that is the enumerative approach. And this was the oldest one. And the idea is quite simple. So the idea in this approach is an economist would sit down and think, what are the vulnerable sectors or what are the vulnerable areas of the economy to climate change? They'll identify these sectors, list them out, and then draw from any relevant literature to devise in some way damage estimates per degree of warming. So if there's 1 degree of warming, it will cause this much damage because of forestry impacts, this much damage due to energy demand, this much damage due to et cetera, et cetera. They then price these damages in terms of dollars and then sum them up across the world in some way to get the total effect of climate change. So there are a number of examples of these types of enumerative studies from the early 90s until the late 2000s. And in my view, I'm going to argue that this kind of approach is indicative of the prevailing economic thinking of the time, that the environment is an isolated object within the economy and the two interact in limited and identifiable ways. So the economist is able to identify all these things properly and price them properly. And I'll give you some examples of how it works. So Toll in 2002, he tries to value ecosystem loss from severe climate change. And he says, well, 2.5 degrees of warming, I'm going to assume, has an average willingness to pay, or how much people are willing to pay to avoid this type of ecosystem loss, of $50 per person on average across the OECD. And he then extrapolates this $50 per hour on average to other parts of the world based on relative income. So for instance, a subsistence farmer in Central Africa might be willing to pay 50 cents a year to not have their surrounding environment completely ruined by climate change. So we will price the benefit of that as 50 cents for that individual in the planet. And there are further examples. So for instance, they look at net mortality change and they argue that, well, the reduced deaths from cold temperatures exceed the number of increased deaths from hot temperatures. So actually climate change can be beneficial to mortality. And for instance, when they look at energy demand, these types of studies would say, well, the extra expense of cooling with air conditioning is exceeded by the cost saved from less warming needed. So we think climate change will actually be a benefit for energy demand and energy costs, and so on and so forth. And that's how the reasoning goes. And you can start to see how these types of studies produce estimates that say, well, climate change is barely going to have any effect on the world economy, or it might even have a positive effect. Next slide. Thanks, Anna. Okay, so then we get to integrated assessment models, and these are extremely popular and have been used extensively, both in academic and policy advice circles. So integrated assessment models are really based on what is fundamentally a good idea, that there is this bidirectional causation between economic activity and climate change. So if you want to give holistic policy advice to governments, you need to take into account the economic costs that in mitigating carbon emissions in the short term, the relationship between the economy and carbon emissions, so economic activity generates carbon emissions, the relationship between carbon emissions and the climate, so carbon emissions change the climate that we experience over the long term, and the relationship, finally, the relationship between the climate and the economy. So will climate change hurt the economy? And for our purposes, a key function in these integrated assessment models is what's called the damage function. And this damage function, it represents the relationship between the climate and the economy. So how does climate change badly affect the economy? And this is used to derive what is called the social cost of carbon, which you may have come across a whole bunch before. And this social cost of carbon represents in current dollar terms the cost of emitting each ton of carbon today. Now, this damage function is really the whole ballgame. It's notoriously difficult to estimate, and different integrated assessment models take different approaches. So when you actually drill down into these integrated assessment model studies and how they obtain this damage function or how they estimate it, you'll find that many of them take the enumerative approach, that as the other studies did, or they do surveys or meta-analyses of papers that are mostly using enumerative methods anyway. So integrated assessment models, in truth, once you realize how they're actually devised, they share really the same weaknesses that the enumerative approach does. And one of these weaknesses that's, I think, is key is that they rely on the economist being able to identify every way in which climate change is going to affect the economy. They rely on the economist making the correct assumptions when devising a way to price each of the individual damages from different sectors or parts of the economy, and then extrapolating the data properly to the entire world. So they rely on the economist doing a lot of things right. And as an economist, I don't do 100% of things right. So that makes me worried that this might not be the correct approach. Next slide, thanks, Anna. Which brings us to the third approach, which is reduced form statistical methods. And this is the more recent one. So the statistical methods take a more agnostic approach to quantifying the various ways that climate change will impact the economy. Given that there's a myriad number of potential ways, this approach instead says, okay, I'm going to collect data on economic growth and weather and historical weather patterns, and I'm going to fit them together in a function. And in this way, I'm going to get the overall impact of climate change on the economy by linking directly the input with the output, the input being changes in the weather and the output being economic growth. So they don't try to identify the different ways that these impacts can occur. They just try to estimate the total effect directly, but using statistical methods. So there's a number of recent studies that do this, both in economics and science journals, and they've obviously received a lot of citations. And we can ask, what is the intuition behind this approach? And the intuition is quite simple. So the intuition is that we can learn about the economic implications of 2 degrees of global warming for, let's say, Kenya, by looking at times Kenya or other similar countries in the past have had heat waves with average temperatures 2 degrees above the norm. So we look back in the historical record of countries like Kenya having severe heat waves, see what it did for the economy, and then say, okay, well, now we have some idea of what future climate change is going to do. And now I'm going to be arguing soon that this is a very bad way of approaching it, but this approach is not without its limitations and problems, but there's a way to fix this approach is what I'm going to argue. And the graph on the left has an example from the Bourke and co-authors papers in Nature. Probably don't have time to cover it. So the idea is that you fit a country's economic growth with average temperature, and you kind of find what is the optimal average temperature for a country to have. So warming will push countries away from that optimal point towards too hot, and that will cause costs to economic growth. Next slide, please, Anna. So what type of magnitudes do these studies kind of give us for the total impact of climate change on the economy? So I kind of touched on this earlier, but now I can break it down by method. So the enumerative methods, Toll in 2009 surveyed this literature and found average predictions ranging from -2% to +3% impact on world GDP in 2100 per degree of warming. So this is really saying that it's going to have almost no impact on world GDP, or if it is going to have an impact, it might even be a positive one. The integrated assessment models produce an estimate of between -2 to -10% damage to world GDP from future climate change. Whereas the reduced form statistical methods, these tend to be more recent and predict worst impacts from future warming. So these studies predict that unmitigated future climate change could cause a decline in real GDP per capita of between 7 to 23% by 2100. Now, this 23% is a bit of an outlier. There's really three serious studies that have done this, and one of them was 7%, one was 12%, and the other was 23%. So those are the ranges. And we see again, I love putting up quotes from these guys, but here's a quote from, again, another influential researcher in this area in 2009, giving his view on what the implications of climate change are. And while, it's easy to, it's easy to take problem with what he's saying, but really what he's saying is a natural conclusion from the types of magnitudes that we're seeing here. If you're going to model that climate change is going to impact world income by 1 to 10% in the negative direction, then why is everyone getting so fussed about it? Why is everyone really trying to mitigate our emissions and induce all of these short-term economic costs for a long-term problem that isn't even really that much of a problem? That is the natural conclusion that one would take reading the vast majority of the economics literature that studies this. Next slide, please, Anna. So the first near consensus view from the economic models is that climate change will have a fairly mild impact on world GDP. The second, which is almost as important, is that the economic models predict that some countries will benefit from climate change, or at least be much less affected than others. And the implications of this result is really immense, because it implies that it's to some countries' advantage to see further warming in the future. And considering the global problem that is climate change and global emissions, this is going to cause a lot of problems for climate change negotiations going forward. These types of countries are usually Russia, Canada, and parts of Eastern and Northern Europe. And we can see on the left here a graph. This is again from the Bourke and co-authors paper in Nature. The blue countries are the ones that the model predicts is going to benefit from climate change, and the red is obviously the ones that will not. And we see a very large discrepancy in the experience of nations. But what is the evidence of this conclusion? So I read all this and I was a bit suspicious. And then when I started to think about how these economic models are built, I came to the following conclusion. So next result, please, Anna. So these models all rely on a very key and fundamental assumption. And that is that a country's economic activity should be related to its own domestic weather shocks and to that alone. And that's how all these models really, through different ways, estimate the effects of weather change on the economy. And what this implicitly assumes is that the climate and weather of its neighbors, trading partners, and world are pretty much irrelevant. Of course, we know in reality, economies are highly interconnected through trade, investment, and financial markets. Economies have structured themselves towards comparative advantage in global markets, not in self-sufficiency. And this assumption is particularly problematic when forecasting the effects of climate change, because we're using historical weather shocks. These models use historical weather shocks to identify the effects of future climate change. The trouble is that historical weather shocks tend to be local or regional in nature. And future climate change is a global shock. So the context in which these shocks occur is very different. And many mechanisms through which modern economies are able to cushion itself from severe climate or weather shocks are going to be compromised from future climate change. So for instance, going back to our example of Kenya. So let's say Kenya has a heat wave in the 1980s and it results in crop failures and pushes up the mean temperature up 2 degrees. The government is able to rely on 3 different mechanisms to stop its population from starving. The first is trade. They can, people can import food using money that they earn from their labor. People can import food to cover the shortfall in their own domestic crops. The government can induce budget deficits. So the government spends to ensure that there are stable supply chains going into the country of necessary goods during this severe weather event. The third thing is if the government is poor enough, and this may be true for Kenya, they may also rely on foreign aid. So they rely on, really what this is saying is that they're relying on these mechanisms because other parts of the world will not experience severe heat waves in the same time that Kenya does. So if Kenya's experiencing crop failures, you can bet in the past that most other countries in the world are not experiencing crop failures at the same time. Other parts of the world might be experiencing bumper crops, and that means they have an overflow of food that's available. And these things tend to balance each other out in the past through natural variation in weather. But when thinking about future climate change, this is a global shock. This is a shock that is going to occur to everyone simultaneously. And you can imagine Kenya having the same heat wave in the future from 2+ degrees of warming and their crops fail. Now suddenly trade and foreign aid is likely unavailable to shore up their food supplies because everyone else is struggling with their crop yield in the same year. And budget deficits are also unavailable because this is a persistent shock. So this type of event is now normal, or it will be normal in the future. So governments can't just continually run up budget deficits and rely on loan forgiveness or future good times to offset them. So by making this assumption, the models are implicitly biasing their estimates of the impact of climate change towards zero, is my argument. And I'm going to show you some evidence that this is the case. Next slide, please, Anna. Okay, so what I'm doing here is I'm just doing a simple experiment to relax this key assumption. I'm going to take two different model frameworks, one from Dell and co-authors in 2012 and one from Kahn and co-authors in 2019. I've done this for a number of different model frameworks, but I'm just going to show you two just as an example. They all give the same result. Because we want to learn, does relaxing this assumption change the predicted impacts of climate change from these types of economic models? And what I do to experiment with this is I modify each model so that it is relating economic growth, not only to weather shocks in their own country, but weather shocks overseas as well. What I'm bringing in is the global context of the climate in which these shocks are occurring. And in no way am I forcing the model to adjust its predictions or to find this external weather events as significant. I'm not forcing the model to do anything. All I'm simply doing is taking existing model frameworks that have been published in very good journals, and I'm giving it more information. And I'm going to let the model decide if that is important in modeling the effects of climate change and economic growth. And then I use that modified model to forecast future climate change and what that implies about the world economy. So the table is broken down by the two different model frameworks. I break it down by closed economy models, and these are the original models that were devised in the original papers, and the open economy models, which are my modifications. I present in numbers the percentage change in global GDP per capita in the year 2100 under two different climate change scenarios. So we consider, again, RCP 4.5, and this is a scenario consistent with warming of between 2 and 3 degrees. And RCP 8.5, which is consistent with warming that exceeds 4 degrees. And we see very, very quickly, because I'm starting to run out of time, that when you modify the models in this way, you get dramatically worse economic implications from future climate change. And what this shows, I think, is just how fragile these two consensus views from the literature are, that the impacts on the economy are mild, and that also that some countries are going to benefit. So when you modify the model in this way to take into account the global context of the climate, what you find is that now the models are predicting that no countries benefit from climate change in the future, none. Some may be less worse off, sure, but it is dwarfed by the overall impact that climate change has on the economy. And I think this makes perfect sense because if you're, let's say, Sweden or Norway, why would you expect to gain from climate change because temperatures get more moderate in your own country when much of the rest of the world is in a prolonged depression and is struggling to grow food and is struggling with a lot of other problems? Obviously, Sweden and Norway rely on external markets for a great deal of their economic output, and it makes zero sense that the rest of the world can be in a prolonged depression from climate change and they will actually benefit. Their economy will actually be better off. It will not happen that way. Thank you, Anna. Next slide, please. Okay, so what I've hopefully given you some evidence of is that this result from the economic literature that climate change will have a mild impact on the economy. This result is very fragile, and I argue that it relies on very tenuous and unrealistic assumptions that are built into these economic models. But this kind of begs a larger question. Can we really have a good idea of how severe climate change is going to impact our economy? Like, how much can we really know right now? Because all of these models make another key assumption, and that is that we have sufficient historical variation in temperatures and the global mean temperature to have information on future world climate states. And what I show you in this graph below is simply what happens to global mean temperature from 1900 until now, and then what these different climate change scenarios are kind of projecting. And sorry, I don't have time to define all these different scenarios, but just know the more up the curve goes, obviously, the more climate change is occurring. And we see that even in the more moderate scenarios of climate change, future climate change is really outside the realm of human experience, current experience. We really don't have any information of what the world looks like when it's been warmed 3 degrees. The historical variation in the global mean is just simply dwarfed by the increase that we're going to see, or that's predicted to be seen by climate models. And this issue really gets compounded in models that rely on weather information that's highly aggregated across space and time, which all of them do. Next slide, please, Anna. Okay, so what does this mean for future research? So for future research, there's a few things that I would want to see happen, and certainly I'm going to be working on this myself. We need to start using disaggregated weather and economic data in these models to help us identify the nonlinear relationship between the climate and the economy. So if future climate change is completely outside our realm of experience, we can't really rely on our annual averages in temperature to identify these types of relationships. And all of these models currently are doing just that. So we really need to start thinking about using more disaggregated weather and economic data to estimate this relationship. Now, the mechanism blind approach of the reduced form statistical methods, I think, has the most potential, but they really need to be married with the integrated assessment model framework, and they can be married together. And this will allow them to not only give more realistic effects of the damage of future climate change, but then also provide holistic policy advice about how much abatement is needed in the short term. And lastly, I would just note that good research in this area really requires expert knowledge from both economics and climate science. We need to increase the amount of cooperation between the two disciplines. And this is something that at the moment scarcely happens, especially on the economic side. And it's certainly something that we need to see more of. Okay, but many of you might be thinking, well, I'm not an academic that works on the climate change literature. I don't really need to know how the sausage gets made. I just want to know what are the conclusions I should take away from this presentation for myself. And what I would really try to drill home to you is that the uncertainty and potential severity of significant climate change is extreme to the highest degree possible. It is an extreme amount of uncertainty, and it's an extreme amount of potential severity. So it's really something that as a species, we really need to be addressing right away. But of course, many of you already know that, I'm sure. But I'd also like to emphasize that you should be wary of any reports or studies that say that they're forecasting impacts of future climate change. Now, I'm not saying that good work is not being done in this area or that the economists are not good enough. Certainly, these things will improve in time and get better, and people are trying their best. But no matter how good they are, there is a limit to how much we can know about the impacts of future climate change. And so we really need to make sure we're aware of that when we read the news headline about what economists are thinking might happen in the future. And what I tried to show you is that it's easy to devise economic models that give the same catastrophic predictions as the scientists are giving. This distinction between what the scientists say and what the economists say, in my view, what I'm trying to argue, it's driven by poor assumptions that are being made in the economic models. And it's very easy. It's not actually impossible to relax those assumptions and produce predictions that are as dire as what the scientists are expecting. On that bright note, I will wrap up. And thank you very much for coming and listening. And yeah, I appreciate your attention. Any questions, feel free to email me or ask in the chat as well. Thanks a lot.
Well, thank you very much, Tim. That was sobering, but a really interesting, insightful discussion as well. It drew a lot of connections for me, things that I'd been wondering but hadn't looked into in detail, and I'm sure many of our audience have been stimulated as well. Please, just as we go through, please do use either the chat or the Q&A tab at the bottom of the Zoom window to ask questions. We've still got 5 or 10 minutes and we can put some questions to Tim. This one, how on earth did closed economy models ever survive peer review? Rhetorical question, perhaps. One of the questions, Tim, I mean, we've all change of government this year. It's a new legislation just passed this week around the emission reduction target, which has been positive. And one of the other things that the new government has done is asked Treasury to resume economic modelling around the impacts of climate change, something that was on hold for a number of years. So while I'm sure that's a positive, do we know anything about how that economic modelling is going to be done by Treasury? Are we going to be seeing the similar flawed assumptions and flawed models that you've just been discussing, or do you think the government's open to rethinking the way these forecasts are done?
Yeah, that's a great question. Thanks, Chris. So it is very good news that not only that we finally passed another climate change bill in Australia for the first time in a decade, but also that Treasury is now getting back to work in thinking about the future effects on the economy. Now, to me, the question is crucial about how short-term they're thinking. So if they're thinking about the effects of climate change in the next 5 years, 10 years, they will certainly have more grounding to kind of base their conclusions on. The more far out in the future that you go as a forecaster, the more uncertain things become, of course, and the more assumptions that need to be made. But the crucial thing is that I really don't envy their task, because it is really a mammoth kind of work that's set out before them to think about how will a change in the global system of things in a very fundamental way affect the structure and the outcomes of our future economy. And what I would point out is that to me, it doesn't make sense thinking about what will climate change do to the Australian economy, because you can't analyze that in isolation. You can't think about, well, what is the climate of Australia? What are the various ways in which climate change will affect different parts of Australia? All of that's very important, of course, but you can't analyze this question properly without also thinking, how is climate change going to affect the United States? How is climate change going to affect China? How is climate change going to affect Africa and Indonesia and Malaysia and all these other places? Because the world is globalized, and so many of these potential impacts of climate change in the future rely on the interaction between countries, not just trade markets, but when you think about the impacts from conflict and war and mass migration and all these other things that relies on, what happens to Australia will rely partly on what happens to Indonesia in 2060 and 2070, and what happens to India and China and all these other countries. So you can't think of countries in isolation. You really need to think of it as a global problem. And what are the effects on the global world going to be? And Australia will certainly be tied to the rest of the world in whatever happens.
Thank you. So, I mean, that sounds doable, but more complicated and less certain once you start trying to expand the economic models to global economy and the complexity that comes with that. Please do feed through any questions. Oh, here we have one from Kevin Fox. Given the unsatisfactory models used to date and the success of scientists in getting the message out, should economists be even more involved in the debate?
If they reform, yes. So this is why I was trying to say on the last slide, we need to get more collaborative work between climate scientists and economists, because if that happened from the early 90s, I bet you that these papers, these huge variety of papers that came out in the early 90s and the first decades of the 2000s in economic journals would not have happened, because at various points in the research that economists are doing, climate scientists will be able to go, well, hang on, that makes no sense. What are you doing? But also vice versa. Obviously, economists have real value to add, I believe, in being able to price different effects and obviously undertake statistical modeling under a great deal of confounding variables and uncertainty. We've developed a lot of skill in these areas. We just need to use them in the right way, use our powers for good. And I think that requires collaboration with climate scientists. Yeah, great question.
Thank you. I know John has his hand up in the audience there. Unfortunately, we can't enable the microphone, but feel free to pop a question in the chat. Just while we're waiting, Tim, another point. I think I first saw this made in Andrew Lee's recent book, "What's the Worst That Could Happen?" And he made the point that all of the models, both scientific models and economic models, in many cases have this arbitrary 2100 end date, and that there's nothing significant about that apart from the fact that it's the end of the century, and that while we can predict the physical systems relatively confidently to that point, things could get a whole lot worse very, very quickly beyond that. Is that true of economic models as well, do you think?
Yeah, certainly. Yeah, so you're right that it's kind of arbitrary. I guess you need to pick a point that's far enough away that climate change really shows its fangs. I think anything beyond 2050 is when these different climate change scenarios really start to diverge. But you don't want to go too far in the future, because the further in the future you go, the more uncertain our understanding of the world is. And people start to think, well, even my great-great-grandchildren won't be alive then, so maybe it's not so relevant for me. Unfortunately, that's the human perspective on a lot of economic costs in the future. Yeah, but that's a very good point, and it's very true.
Thank you. We're just about on time, but there's a point here in the chat as well about the challenge of forecasting the future based on historical data, which I guess is well understood and dealt with as best it can be. Do you have any comments on that, Tim?
Oh, I mean, even in the best of times, it's extremely difficult to forecast anything in economics well. But, to me, it's kind of, in weather itself. So forecasting the weather tomorrow is maybe I'm completely mischaracterizing it. And if there's a scientist in the audience, please email me if I'm making a mistake here. But as I understand it, predicting the weather tomorrow or in the next hour is way harder than predicting the climate in 2050, because there's just so much more randomness involved. And it could be the same thing here for the economic impacts. Certainly, we know that the world, I think we have enough evidence from the sciences, and we will soon hopefully get this evidence from the economic literature as well, that the world's going to be in a very bad state from these more severe scenarios of climate change between 2050 and 2100. And, I'm more comfortable in believing those forecasts than I am in forecasting what the interest rate is going to be next year, if that makes sense. Yeah.
Sure.
In some ways, it's actually an easier question, and in some ways, a harder question. Yeah, but that's a good point.
We are on time. Just one more question we've got in the Q&A here from John Piggott about the handling of these challenges in the financial and insurance markets, whether there's a more sophisticated approach to interdependence in the corporate sector, I guess, where people are making a living or going bust on the basis of how well they do this work.
Yeah, no, that's a great point. So climate risk in financial and insurance markets are a huge deal right now, because we're already starting to see the effects of climate change in our world already. And certainly in the next 10, 20 years, these are timelines that these firms care about, that, an insurer might not care about what happens in 2100, but they certainly do care about what happens in 2025 and 2030. And international independence is just as crucial a point for these markets. I would hope that financial economists understand this, especially considering how this is how every other phenomena in financial markets work. Everything's so highly interlinked. But that's a great question. Thanks, John. And thanks everyone before we take off for attending, and thanks for your comments. And I'm very happy to hear them.